All right, we are back on the Monday Morning Haskell video blog series. We're writing our Haskellings program just to make an automated tutorial for people trying to learn more about the basics of Haskell. Let's just take a quick sort of peek at the current status of our project. And this is going to motivate a couple things that we're going to change this week. So right now if we do Haskellings run types 1, we see that we get sort of this error output. And we also see like the compilation output. And this is like a little strange. It would be nice to get more clear debugging messages from this. And especially since if we go and we correct it, and in the successful case, it would be nice to just be told that it's that is a success, rather than seeing these compilation messages that aren't really all that useful. So in this video blog, we're going to try to correct that. We're going to go into the inner workings of the process that we create when we go ahead and compile our exercise, and we're going to just take over the handle processes that actually create this output, so that we can produce output that's more useful to the user. And in the process of this, we're also going to get a little bit of a glimpse of using colors in the terminal in Haskell. So let's jump right into it. In types 1, don't care. If you want to go to our utilities module, which is where most of this is going to take place. The first thing we want to do is that it's generally going to be a good thing for us to actually return the exit code. This is essentially what happens when we wait for a process. We'll get the process's error code, and this will be useful down the line. But we're also going to make another alias that has this, the old type signature, basically. And this is just going to exercise, and we're just going to say void. I'm just going to get rid of that exit code, just for backwards compatibility for the moment. The remainder of our code, so run exercises, we want to just ignore that for right now. And watcher will also go ahead and ignore that. Just quick double check that code is now building. Okay, so we're backwards compatible, but now we're going to start looking at this exit code and what exactly it means for us. Get out of these two files; they won't need to change. We're just going back into our utilities module, and so we'll get basically this exit code. And we might want to print different statements to the user depending on that exit code. So there are two constructors. There's the success case. Actually, it's exit success. One thing there, and then we can also exit failure with, a code. We're not going to do anything with that. That's an integer. We're not going to do anything with it too specifically right now. But we'll go ahead and just put a helpful message, say, line successfully compiled our exercise. And down here, and we'll just return the exit code just for later we'll eventually want that, and we'll do something very similar here. We'll say could and compile that, and again we'll return the exit code. So now we're printing some more messages that are potentially useful to us. So it'll be a good time to check up on how our program is doing. So if we say now it just tells us, okay, successfully compiled types 1. There was no output that time because nothing had changed. But there, now you know, we get this message at the bottom, but we're still getting all this other junk that isn't necessarily in the right order that we want it, or in the case of this, you know, the standard output, we don't actually want a user to see this necessarily. So how do we stop that? And the answer is we go into our process, and so the system.process library has a type called createProcess, and when we call proc with all this information, we're creating something of that type. So we'll call this calls our process spec, and that's actually what we're really doing here. And you know, if we're using scope type arrows, this is the type of this. We have is a create process object. So in order to actually pass that, we will pass that as an argument here, ignoring all of that. But when we don't provide any arguments to this, it's going to use the standard out and the standard error streams by default. And we actually don't want that in this case. We want to create our own pipes so that we can control how much of that information the user actually sees. So the way we can do this is by modifying our specification. We will start by saying, okay, standard out is equal to create pipe. So now it's not going to inherit you know, standard out, which is what our process is using right now. It's going to create a new pipe, and we can actually get that. We can get a handle for that from the output of create process. So in the case of standard out, it'll come in this second argument, but we don't even really care about the standard output. You know, the standard out stuff, the like linking and the listing of the modules, we don't really want to see that at all. So what we should see, in fact, just by hiding this and by not using it as standard out, is that those that information will disappear. So let's just see if that worked for us. Install. Okay, so we can see that we've succeeded in getting rid of, you know, the compiler, some of the compiler message. We still see the errors because those are getting put to the standard error stream rather than the standard out stream. But now, just as a hypothetical, we'll implement it, so it's not hypothetical, but let's say we want to sort of reorder this so that we put this message can compile ahead of our other output. How would we do this? And the answer is we're going to override standard error just like we overrode standard out. Make that another create pipe, and this time we're actually going to go ahead and grab that handle. So the process standard error handle is what we'll grab here. And so in the case that we have a failure, we'll print this message first, they couldn't compile, and then we can actually go ahead. This is actually a maybe object. It may or may not return a handle for us depending on the status. So we do have to do a quick case check there. So if it's nothing, we're just going to go ahead and do nothing, basically. But if we, in fact, we have a handle, we're going to get the contents of that handle. And now, at this point, is when we're going to put that to the terminal after we've, you know, printed our original message of being unable to compile. So let's go ahead and try that again, see what kind of progress we've made. Whoop, I misspelled something. Oh, I did not need to fully spell out errors. Oh, and we need to actually say H. We get the contents out of this handle that we've just pulled out, and we pass that to put string line to print it out. And now, we see that our message, the green compile, comes first, and then it prints out the error stream. The one thing that we've sort of lost here is that the original error output had its own sort of color scheme, and we're not able to replicate that if all we're doing is printing it out. I'm not sure how to replicate it. That's a little trickier, a little more complicated. Just because the coloring of that text is probably internal to GHC. But one thing we will be able to do is just color all of our output to a particular color. First, I do want to show what the success case looks like right now. So if we go ahead and make this correct, so now it just says successfully compiled. We don't see any compilation messages. Now let's just make it so that if we successfully compile it, it's green. If it fails, we'll just make the text red. And to do that, we're going to use the ANSI terminal package. I've imported it here, system.console.ansi. And the API is pretty straightforward. In the success case, we're going to use a set SGR function. I actually don't know what SGR stands for, set screen something. But there are a variety of different elements you can pass this function, and the one we're just going to pass here is we're going to set color. Foreground or background if you want. And every color sort of has vivid and dull, so we're going to use vivid, and we're going to say green. And then once we're done printing our messages, we want to reset it. So we'll say reset. And we'll do basically the same thing down here, only we will make it red instead of green. So let's try one more time. Change our file again. Okay, so now our text is all red. It, we say we can't compile it. It's types 1, and then we see our error message pointed out right here. If we go back and we fix the error, now we see successfully compiled, and our message is green. So that's really cool. It'll also work if we're in watch mode, just because we're sharing this function. Yep, so we see it there. And now it says running exercise, and we see that it succeeds. So that is all we really need for this little feature. And now that we know if our exercise is really succeeding or if it's failing, this opens up the door for us to really augment our watch mode. So next week we'll, I think I maybe promised to do this week, but next week, in fact, is when we'll be going a bit deeper and creating a list of exercises and showing how we can go from one exercise to the next. So stay tuned for that.